Right stretch. Welcome back. So we talked about primary hazards, ash, lava, gas, pyroclastic flows. Pyroclastic flows being the most dangerous to life of the primary hazards. Let's talk about secondary hazards because there's a bunch of them. We'll just highlight a few. For instance, fires. It wasn't the lava flow that burned my house down. The lava flow created a wildfire. The wildfire burned down my house. All right. So fires, earthquakes, when they erupt, or even prior to eruption, you can get some quaking. Lahars, we'll describe what those are, and the tsunamis, as well as we'll touch on a little bit about climate change due to eruptions. So again, fires, hot lava may ignite plants, may ignite structures, create wildfires. Pretty self-explanatory. Earthquakes usually accompany or precede volcanic activity. Sometimes an earthquake occurs because of the rumbling of the material moving up and out, or after an earthquake, it can create an earthquake as material is landsliding or falling down. So these are both secondary hazards. And then what about lahars? Lahars are debris flows, mud flows, landslides. They can come in a few different flavors. One, you can get loose volcanic ash. So let's say after an eruption, maybe a larger Pleiadian or Planian eruption, there's a lot of ash everywhere. Well, if it rains, if it's saturated with water, it rains, well, that water kind of becomes this slushy mud slurry, becomes unstable, and then all of a sudden comes rushing down a mountain or rushing down a volcano. So that's kind of one flavor of lahar. So debris flows. Sometimes if there is large amounts of snow or glacier or ice on top of a volcano, and even if it doesn't necessarily erupt explosively, if it just starts to release a lot of gas and heat, it can melt that material. That ice or snow, that melted ice or snow becomes water as it rushes down the side of the volcano, picks up mud, debris, sticks, twigs, rocks with it. Kind of just starts to flow out. And these can flow for many miles. Mud flow, a little bit finer than a debris flow. So debris flow, kind of a bigger chunks, trees, bushes, rocks. Mud flow, kind of smaller material. And then you can also get landslides, kind of just sliding off of the volcano. Doesn't necessarily have to deal with water mixing in with other material. So here's an example of a mud flow. You can't see it in the distance. A volcano creating a lahar, in this case a mud flow, came rushing down the valley, essentially burying the valley. The mud stops. Once it dries out, it solidifies. You're not getting much out of there. So some famous examples of lahars can really be talked about surrounding Mount Rainier National Park. Or Mount Rainier, the volcano itself, the stratovolcano. So they tend to erupt in general explosively, but Mount Rainier is kind of a unique one. Historically, it really hasn't erupted huge. It vents a lot of heat and other gas out of the sides of it, but it hasn't, at least historically, kind of just blown its top. But Mount Rainier is within eyesight. If you're in Seattle, you can see Mount Rainier. Tacoma, another big city up there, is pretty close to where Mount Rainier is. So if this is 10 miles, so it's about 50, 60 miles or so. But since Mount Rainier has a history of releasing heat and gas, and Mount Rainier is perpetually covered in glaciers and ice and snow, well, when you heat up that stuff, it turns to water. That water kind of rushes down, and there's a number of rivers, streams, and valleys that naturally come off of this mountain, off this volcano. And so historically, there have been lahars that have traveled many, many miles. In fact, some of them have even made their way all the way to the Tacoma area, historically speaking. So yeah, I mean, these flows can travel for a long distance. So what I'm trying to get at is, even if you're not even near the eruption, you might get one of these flows heading your way. So it's hard to get out of the way of the effects of a volcano. Tsunamis, volcanic landslides, or even eruptions underwater in or next to the ocean can trigger tsunamis. We talked a little bit about that last unit, 2 units ago, excuse me. And then climate change, global cooling due to large eruptions. So if you get a large amount of material going up into the atmosphere, it can reflect back sunlight into space, block sunlight from getting through, can actually cause the world to change in temperature, as well as a number of other nasty side effects. So that's it as it pertains to secondary hazards. I mean, there's a number of different ones we can go through, but what we'll do, we'll pause here, and then we'll kind of take a step back and see how all of that has an impact on society. What's affecting us? How's it affecting us? Where is it affecting us? When is it affecting us? That's what we'll look at when we come back. I'll see you in just a minute.